Hey everyone, welcome to part 2 of your week 6. We hope that up to now you have learned the basic about classes, know how to define a class in CPP, and have a knowledge about its objects, data variables, and member functions. So, for this part, we actually divided the whole into the ratio of 30 is to 70. That means today at this session, we are going to cover 30% as a theory, and the remaining 70% would be the live practical by programming the main programs. Before actually going to start, I would once like to just have a quick recap of what we already discussed. So, up to now, as you know, we have tried and taken forward the type of inheritance. We have learned the basic of access specifiers, and in today's lesson we are gonna go deep into the particular access specifiers, that is public, private, and protected. Apart from it, we are gonna examine the different type of inheritance. As before, we have discussed about the single level. Today we are gonna go deep into the multi-level and a multiple inheritance. So, without any further delay, let's get started. As we all know, there are three kinds of access specifiers in C++. First, public, second, private, and third, protected. As we have seen up to now, any class that have public member functions or data variables, or you can say the data specifiers, can be accessed with the use of the class object and a dot operator. Now, let's have a look to a class with public access specifier. In the very first program, you can see that we have a class with name circle. This class is generalized as a public class which have a variable of double type with name radius and a member function again of double type to compute the area. This function is actually computing the area of the inputted radius, where we just use the basic mathematical explanation for counting the area, which is 3.14 multiplied by square of the radius. So now, as you can see in the main program, we have specified the object of the class circle with the name obj. Now, as we discussed before, to accessing any public class, we need not to do anything else but only to specify the object of the class dot operator, and then we can actually access the data member, which is radius in this case. At this point, we entered 5.5 as the radius value, and as the output, we are calling the member function compute area at this program. Now, let's try by changing some values, where I'm gonna enter the value of radius as 10.41. Let's tap run and see what the output of the program would be. So here you can see that the radius is 10.14 that we have entered, and the area is 340.276. So this is in the case of a public class. Now, what if I'll just change it to a private class? Oops, that's a typo, and yeah. Now, as you can see here, it's showing errors whenever we are trying to call any of the member function or the data variable from the class, as this class is protected, or you can say this class is private, so it can't be accessed directly. So what if we have to do with a private class? In this case, we have this program created specifically to access the data member and a member function of a private class. Again, we are calculating the area. Now, to do the same, we actually initialize the class with private access specifier, and we have created a function that is the member function of the class, which is specified public. As you can see here, the data member is private and the member function is public. We are actually at this point providing the output within the function, as this function is inside the class. So whenever a function that you can consider as a member function is there inside the class, it has the access through its private data members. So for this case, we just did one thing, that in spite of calling or in spite of retrieving the private data member into the main function, we actually taken it within the public member function, where its use is being specified in terms of calculating the area at this case. And here at the main function, we just created an object in order to call or to utilize the member function, which is public. Now, for an instance, what if I will just comment this? Let's have a run and analyze the errors. Again, you can see these errors, and the reason behind occurrence of these errors is, as we have discussed before, whenever the access specifier isn't being objectified in a class, or whenever it is declared private, it can't be obtained just by using a simple dot operator followed by the object. Let's do it back to public, and let's actually try to change the value of radius. So here, as this function is actually passing a double value of radius within it, we are going to specify this value this time as 18.70. As soon as we put it to run, here is the output. The radius is 18.7 that we have entered, and the area is 1098.03, which is the correct explanation. Now, let's move ahead and have a look what happened if we do the same for our protected class. Or even before that, let's try to convert this private class into a protected class and see what errors we have to face. See, even at the part of protected class, we are able to get this. And the reason behind this is that we actually made the function that is compute area as public, and the parameter of radius is passing within the function as a parameter. Now, let's have a glimpse overview that how a particular protected function takes to work. For instance, we have created this particular program to demonstrate the protected access modifiers. Now, here, so before actually getting into a program, let's just have a small look that what is being specified here as this, which is actually inheritance, is being used here. This might seem a bit unfamiliar to you all, but if you remember correctly, we just have introduced inheritance in the previous session. Now, when we are considering the inheritance, for now, you don't need to worry, even if you're not very familiar with it, as in the upcoming time, the next topic we are going to cover in today's lesson is itself multi-level and multiple inheritance. So this would be in great use there while we would be considering the inheritance. So here we actually started with a class with name parent, which have a protected data member that is ID. Even let's make it a bit shorter and remove the protected here and any part where it is being used. Okay, now let's make it to ID and let's correct over this part so that it would be easy to understand for each and everyone out here. So now in the class parent, we have the protected data variable, or you can say the data member with the name ID and with the type integer. Now we have a derived class, or you can consider a subclass with name child, which is being inherited directly from its parent's class named parent. Here we have a public member function with name setID, in which we are passing ID as a constraint of integer type. Now, at this point, we have to be sincerely considerable as we have changed the name, but we also have to conclude it over here as the ID is being already used. So this point, our compiler gets stuck or might get interrupted or be confused, which will be result as an error. So let's just change the name with IDD of the member variable in the place of ID. So here we are actually providing the value of ID to IDD so that it could have a specified value. Now we have another public function, which is a void type function, display ID, where we are just simply displaying the inputted ID by the user. Now, starting with the main program. In the main function, we have first clarified the obj1 as the object of the subclass or the child class, or you can say the derived class child, where we are actually calling the public function setId and display ID with the help of object followed by a dot operator. Let's have a quick run to the program. Here you can see we have provided the value in a function of setId, ID as AD1, which is being later on setted as the value of IDD, which is a protected data member or data variable of the main class, or you can say the parent class with name parent. What if here, if I will change this into a floating type number, 5, let's say 100.51. Here you will notice something, which is actually the type conversion that we have covered in our previous topics. So here, as we entered a floating variable, but the parameter here to be passed must be integer type. It is neglecting any value which is after the decimal point, as an integer isn't being considered any decimal value in C++ programming. Now, what if I will just change into this into float? So now you can objectify that even now it is just not providing the float value. And now if the reason being considered here, then you can see that we're actually providing the value of IDD, which is integer type itself. So in order to convert this into a float type, we actually have to specify this as a float value. Now, as soon as you run this, you can see that we clearly have a floating value. Now, what if I will do something which is vice versa to the previous one, and I will just pass 100 over here. So it's 100 as nothing base concluded after a decimal. Now, again, let's convert this into floating type by introducing a decimal value here, that is 100.81. Now, what if I will make it back to integer type and have the protected data member as a floating type? Now, again, this is just outputting the integer value, because the value here parameterized isn't considering the floating value after the decimals. Now, let's just convert it back to a float and just let's have it run. So, the motive behind illustrating these multiple examples of very basic changes in the program is because by doing so, we are able to objectify or to consolidate the programming, and this is a generalized and a best way of learning. In spite of all the theories that you learn or all the programs that you might try to memorize, you will not able to create something which is noble or logical until or unless you try multiple things and faces multiple attempts. So here is a key tip to note: whenever you're considering programming, it's irrespective of any of the language that you are specifically using, just try to change the program as per your different opinions and try to put different things at the different places and notice that what changes happens. This will help you to get the fundamentals of any language or any topic that you are trying to learn. Apart from this, this will actually solidify all of your basics and make it more rigid. Now, as we are clear with the access modifiers, now let's look back to our slides and go to our next topic for today. These are constructors. Now, constructors are special class members which are called by compiler every time an object of the class is initialized. Constructors have the same name as a class and may be defined inside or outside the class definition. So, as this definition clearly mentions that constructors are special class members, so they are called itself whenever the object of a class is objectified or initialized. Their name is as same as the name of the class, and they might be defined within the class definition, that is inside the class definition, or even outside the class definition. Now let's have a look to the three types of constructors we are going to cover in today's session. The first constructor is a default constructor. The second one is a parameterized constructor. And the third one is a copy constructor. Now, the best way to understand each of them is by actually noticing them in a real program or applying them by creating a real program. Let's hop back to our examples. So here we already initialized an example for you to illustrate constructors. As you can see, we started with a class with name CON, which have a public data member of type integer with name ID. Then we have our constructor. Now you can notice one thing, that the constructor is actually having the same name as a class name, which is CON in this case, where to demonstrate it, we actually just put it within the definition of that constructor, that it will output that a default constructor is being called and set the value of ID to be -1. Now, when we are talking about parameterized constructor, at the parameterized constructor, we actually, as the name suggests, parameterize it with a constraint and pass it within the constructor. In this case, again, the constructor will be as same as the name of the class, that is CON. In this case, we have a parameter of type integer and name x. Here, it is just simply outputting that the parameterized constructor is being called and giving id the value of x. Now, let's see how this value of x is being inputted. So, as we can consider in our main function, where we have defined the object of the class with name obj1. So, if you remember, just few minutes back in the slide, we have stated that a constructor is being called as soon as a class object is initialized. At this case, as soon as we initialize the class object with name obj1, the default constructor is being called and we are outputting the constructor id, which in the first case is -1. For the next sign, in order to call the parameterized constructor, we are just again initializing the object 2 as the object of class con and passing the value as 21, or let's have it 1 for now, and then outputting the value of id, which is being provided here with the value of x. As soon as we run this program, we can clearly see that the default constructor is being called, which is being calling at this place where we are initializing our object 1 for the class con, and this the value of id to be -1 is because here the default constructor is being called, which is providing the value of id to be -1 as according to the definition of that particular constructor. On a second, as soon as we are initializing the object 2 and passing the parameter, where in this case is 1, which is actually being getting saved according to the parameterized constructor definition to the value of id. It is then printing the id, and here, if you can see one thing, that's as it's being public. Again, we are using the same way, calling by object followed by a dot operator and then the member function or the member variable as required. So the output is parameterized constructor called according to the definition, and then we have the value of id, which is being 1 as we pass 1. As soon as we change this to 10, here the id would be 10, as you can see in the program. Similarly, we can do this with the id that we specified at the definition of the default constructor. It would show now -110, and here it is. So now you have seen that how constructor is being called, what is its use, and how it's being used in a program. Let's again hop back to slides. So we have seen the default constructor and a parameterized constructor, where the copy constructor, which is the third type of constructor. A copy constructor creates a new object, which is exact copy of the existing object. The compiler provides a default copy constructor to the classes. So the syntax for a copy constructor would be the class name, and within the brackets, class name followed by an AND operator, and then we can justify the definition of the copy constructor as per the requirement. Now, while you have seen the constructor, so whenever a constructor is being called, a specified memory is being allocated. Now, as we all know that all the programming that we do is to create things more optimized, or all the algorithms that we do is in terms of reducing the complexity of the entire program, or we can consider the entire module. Let's have a look to our next topic, which is constructor. So constructor is another special member function that is called by a compiler when the scope of the objects end. So now in any program, whenever we initialize a constructor, it is always important to free up the space that the constructor have occupied or the data member have occupied. So in order to do this, we use constructors. Now, as the definition suggests, the constructor is another simple, or you can say the special member function that's called by compiler when the scope of the objects end. So as soon as the scope ends, the constructor is being called by itself. Now, for this, let's again hop to a live program and examine the example with a live usage. So for this, we have the program here where we have specified a class with name DES, which have a public data member of integer type and with the name ID. Now you can see here we have defined a constructor. Again, we defined it with the name of DES followed by the symbol. So whenever initializing or defining or giving definition to any of the constructor, you have to keep in mind that you have to use this specified symbol before the name. Now, in order to see that how constructor is being called or how is being used, we actually provided a definition that is simply outputting the constructor is called for ID that we initialize as a public data member. So the motto behind outputting this is to make it more user friendly and easily understandable by each and everyone, so that as many times as the constructor is being called by the program, you will see this statement and can identify that what is happening. So now starting the main function, we have created an object with name obj1, for class DES. Then we provided a value by using the object followed by dot operator and a member variable or the data member where we have specified the value of ID to be 7. Then here we have initialized another variable I, which we are basically initialized for the looping purpose. So as we can see in the condition of while loop, till the value of I is less than 5, which is 0 in start. So this loop will actually execute 5 times. That is, first time as a value 0, then we increment to 1, then 2, 3, and respectively to 4. Then we actually here initialize the second object of the class constructor. So why we did that, or what's the reason behind it? So the mere reason behind it is simply to output the number of times a destructor is being called. Now we have provided the value ID as the value of I so that it will continue to be in a loop. And as we can see, the scope of object 2 ends here. That means it is executing 5 times 0, 1, 2, 3, and 4. It must increment the value of ID up to 4 and must print a statement at a destructor or within the definition of the destructor 5 times starting from 0 to 4. Now as the object 1 ends here, like the object scope ends here for object 1, which is being described at the very beginning, it must again specify the ID value to be 7 and must call the destructor once more time. So let's run this and see what happens. Now you can see clearly this is what really happens. Now it's being called the times, like first time with the value of I0, then I1, then I2, then I3, I4, and now for the object 2 it ends here. Then this ID to be 7 is printed because we specified at this at here, where the scope of obj1 actually ends. So again here the destructor is being called. Now let's see what happens if I will just initialize another object with obj3. So here now you can see that at this point it is basically repeating the destructor called for the ID4. And the reason behind this is that at this time here are the scope for object 1 and object 2 both and simultaneously here. So for object 1 it is taking the previous value of I, which is after the looping function or the looping thing is 4, and which is being changing here to be 7. Now if I will just do one thing and provide the obj3 as a value of 9. So you can see now we have this as a value 9. And if you can notice a mere thing here, that it is being called before the obj1. And the reason behind this is that the leader, like, okay, so like if we will like define this object 3 previous to the object 1, it will actually be called before, like the object 1 will be called before the object 3. And the reason behind this is that the scope of object 1 at this case ends just before the scope of object 3 as it's been defined before. So you can see, we can see the variation that first the destructor destructed the memory allocation for object 1 and then shifted to the object 3. So now I hope you all are clear with the use of destructor, and as you know, it holds a solid and a very vital role in programming, as it helps in the operation of optimization by reducing the memory allocation and making the program more better and well optimized. Now, let's hop back to slides and see our next topic. So, after destructor, we are here at our next topic of multi-level inheritance. Now, as we've noticed that inheritance plays a vital role whenever we are programming. Either it can be a software or it can be a specific program objectified to solve a specific and a more general program. We can see the multi-level inheritance is actually a class is also being derived from one class, which is already been derived from the other class. So what happens in a multi-level inheritance is that the class C, as you can see in the diagram, is derived from class B, and the class B is derived from class A. So the class C can be able to access the member functions or the data members or the data variables of class A, while class B would be able only to access the data member or the member function of class A. Let's have a look to a live example for this, where we have the base class with name my class, which have a public function, which is my function. Now, we actually created a derived class with name my child, which is being derived from the in a public method from my class. So here, this is the first level of inheritance that you can see. Now, there is a class with name my grandchild, which is being inherited or derived from the parent class, which is my child for this class. Now, in the main function, we're actually just creating an object for the class my grandchild, which is my object, and we're accessing a function whose definition is being defined publicly in the main parent class, which is my class. So as soon as you put run, you can see the member function is being called here, and as we have put it, which is some content in a parent class, has been shown in our console screen. So this is the example of multi-level inheritance. Now, there is another type of inheritance that we are going to cover today, which is multiple inheritance. Despite of multi-level, let's have an example of class A, class B, and class C. Here, the class B is a derived class which is being derived both from class A and class C. So here you can see a class can also be derived from more than one base class. And for this task, we are actually gonna use a comma to separate both the classes. So let's have a look to its program. So at this program, you can see we have again a class with name my class. We have another base class, which is my other class. At my class, we have the public member function, which is my function. And similarly, in the parent class, that is my other class, we have another public member function, which is my another function. Now you can see in a derived class, what we actually did, we actually inherited the my child class from the public my class and publicly from my other class. So in this way, now as we objectify the object for my child class, which is my object, and with this object we are able to actually use the function of my class and my other class both together. Let's run this program. Here you can see here some content is present in the class, which is from class my class. So let's just name it like for a better view, let's just name it as my class, and let's do similarly for this. And like before that, like let's just put a backslash n in order it would be printed in the next line and looks a bit better and don't mess up within the same line. My other class, and as soon as I tap run, you can see we have both the member function being accessed by the derived child class, which is my child class, that is showing as a result at the console screen to be my class and my other class. So this is all about both the type of the inheritance that we have covered today. Now let's just hop back. So now we have a small use case of the class. You want to program a grading system for students. So by using classes, you actually program a grading system. And how would you organize your information? So here are some tips. Create a student class that shows grades from each assignment and exam. Create a grading program that calculates the grade based on the syllabus percentages. So this you can consider as a mini project for you while doing the classes. And as well as this is actually a part of your assignment, or you can consider as your homework before moving to your final project. Now have a hands-on practice with classes. Design an animal class and leave comments for each component to explain your design choice. Define two variables, name and age in this class. Now, in addition, create two subclasses, which is being derived from the animal class, and those subclasses would be cats and dog. Now, there's something to note. It's okay if you're unsure about it. We just want you to ask questions from us. So comment down the video if you feel any difficulty or have any doubt to any topic from the very beginning of the course to up to now, the use of classes. We would be happy to holding the office hours for you to solving your problems and provide a better solution. Now, So this means you to get familiar with classes and don't stress too much about it. Programming isn't just mean to be taught or to be learned within a single day. It takes time. And this really happens because good things always take time. With POWAN, we are always here to help you out. So, on concluding our week 6, we are just about to end this bootcamp. And now for our final week, we just going to initialize a major project at the end. So thanks a lot everyone to consider us as a partner of your learning up to now. So I, Vinam Sharma, is being signing out for week 6, and you will guys will see me in the upcoming week 7. Let's have some real fun with a project for you in a week 7. Till then, keep learning and keep on exploring. You have so much to do